is the typical example that we will work with, which is going to be just a quadratic function. So let's write something like x squared minus 2x plus 3, something like that. And we're going to go ahead and compute this derivative by the definition. So I normally break this up into procedures, into steps, because it becomes a little bit untractable if you don't. So let's start by computing just f of x plus h. Why would we do that? Well, that's the first term that we have here. So I want to compute that term separately and simplify it as much as possible. By the way, this procedure is mostly for polynomials. Once we get into rational functions, we'll work differently. But let's start with polynomials. So we're going to plug, whenever we see an x, we plug an x plus h. In parentheses, remember, you always want that in parentheses. Minus 2 times, now there's an x, I'm going to put x plus h. Then plus 3, there's no x, so I don't care. I just write it as it is. All right, so now we're going to do some algebra. We're just going to FOIL this out. So we multiply here. So remember your x squared, square of the first, 2 times the product of both terms. This term is the one that everybody forgets, so don't forget about that guy. And the square of the second. Then we're going to distribute these two. And we get that expression. All right, so that looks quite messy, but imagine if I'm plugging this in here, and then I'm going to subtract f of x. That becomes a mess. But you guys know how to subtract, like you guys did in elementary school when you did it with numbers. If you put negative f of x below, and you match them, this term with this term, minus negative, so this becomes plus, minus 3, and you match them, you see how they cancel out. And you subtract like you would have done with numbers. X squared minus x squared goes away. 2x, h, copy that guy, doesn't cancel with anything. H squared survives as well. Negative 2x and 2x, they go away. And minus 2h. So you see this expression right here is f of x plus h minus f of x. And that is the numerator of my expression for the derivative. So I can grab that and put it in my expression for the derivative, and then I'm going to compute the limit. So let's go ahead and do that. I think I'm going to move over here and do it here. We have enough room. So f prime is going to be the limit as h goes to 0. Just copying the definition here. And then I'm going to plug in the numerator, which I copied. And let's copy it with its color so we follow what happened. 2xh plus h squared minus 2h. All over, that's just copying from the definition. All right, and when we have that, all we have to do now is factor an h out of this, because we have an expression of the form 0 over 0. If you evaluate h directly, you get 0 plus 0 plus minus 0, 0 over 0. 0 over 0, we cannot divide by 0, so we got to do the limit. And so when we do the limit, we will factor this h out, because that's the guy who's causing trouble. Because that gives me 1, 0. And then I divide by h, h that multiplies, h that divides. In the limit, I can cancel it out, and I just get. And that's the importance of the limit. 0 over 0, you couldn't divide. But since you're doing it inside of the limit, you're avoiding that h equal to 0. And now you just have 2x plus h minus 2. Which, in this case, I can plug in h equals to 0, and I get 2x plus 0 minus 2, 2x minus 2, and that is the derivative of f. So I wrote it right here. I wanted to write it here, but I kind of didn't have room, so let's put it there. So that is right there how you would compute the derivative of a quadratic function. Now, if you were to have a cube, for example, here, then you would have to expand this cube, and you would have to then do x plus h times x plus h times x plus h, or you do FOIL the square first and then multiply times x plus h. Another way of doing it would be if you use Pascal's triangle, and I'll let you Google that one. Or maybe I'll do a lecture on that separately. All right, let's go ahead and move to another example where we do a rational function. So let's now talk about a function, just a rational function. So these are the typical examples you will encounter. So for example, x plus 3, 1 over x plus 3. Now, the trick that I taught you for the quadratic doesn't quite work. So here, unfortunately, is a little bit more messy. You'll have to work with that. But there's not a nice way of breaking it up as we did before. So we start right away with the definition. And here I'll have f of x plus h. And just so that we can see things better, I'm going to put them in two different colors. Unfortunately, I didn't think about it fast enough. I could have done this one in a different color, but oh well. So what I'm going to do, I'm going to plug in f of x. Whenever I see an x, like here, I'm going to put an x plus h. Everything else I copy the exact same. And even though I don't need parentheses here, I'll put them just to do as I say, so I can be consistent with what I say or tell you to do, so you don't make mistakes in the exam. Now, minus f of x, so I'm just going to copy f of x. So the first guy is f of x plus h, second guy is f of x. And now you have a fraction that the numerator is two fractions. So that's like the worst nightmare you could ever have. But it's not bad at all. Firstly, let's make it look less intimidating by remembering that dividing by h is the same thing as if you multiply times the reciprocal of h. So I can multiply times the reciprocal of h, and I have this expression here. I'll drop the parentheses because I don't need them anymore. I have operated whatever needed to be operated. And I get that expression right there. All right. So I wrote, instead of this big division, I just wrote it as a factor. It looks a little bit nicer, but I still have a difference of fractions. So what do you do with that? Whenever you see an addition or a difference of fractions, you should immediately think about a common denominator. I know, not everybody does, but you should think about that. So 1 over h, and I'm going to do a common denominator where in this particular case, there's no common denominator between them, so I have to multiply the two factors, and then I cross multiply. X plus 3 times 1 is x plus 3, and then x plus h plus 3 times negative 1 or minus times 1. We write it like that. And now we can do some algebra. This is the crucial step of this problem. Once you clear this hurdle, everything is easy now. Because you do x plus 3 minus x minus h minus 3 by distributing the negative. And you'll see a lot of things will cancel, and things will be nice after that. But the crucial step is to remember that common denominator. Once you do that, you got it. So here, the x and the minus x cancel, the 3 and the minus 3 cancel, and I'm left with just a negative h. Negative h in the numerator, h in the denominator. You see, the common thread here is that we are trying to eliminate that h in the denominator. Why? because we don't know how to divide by 0. But in the limit we can. So h that multiplies and h that divides, they cancel. Of course, you have a -1 implicitly here when you cancel, so just remember that. So you get the limit as h goes to 0 of -1, because you had negative h divided by h, leaves you a -1. And then you get x plus h plus 3, x plus 3. But now if you plug h directly here, as h equals to 0, nothing bad happens. There's no 0 in the denominator. You get x plus 3. So you would have -1 over x plus 3 times x plus 3, right there, which is -1 over x plus 3 squared. And that would be your derivative of f when f is 1 over x plus 3. Example 3. So this is going to be, again, f. I could call it g, but now I called it x. So do a radical square root. Let's say 2x minus 1, perhaps. Why not? All right, so here this is another one where, by the way, I needed f prime of x here. This is another one where the trick of separating it doesn't help us. So we are going to have to write it all out. And this time I'm going to be more cognizant of my colors. And I'm going to write the first one with the, what is it, yellow? Why not? Over h. So that first one, now this one you do want to be a little bit careful because there's a 2 in front of that x. So your parentheses are extremely important. So don't make that mistake there. So let me write it in yellow. It's going to be f of x plus h is going to be the square root of, and when I see x, I plug x plus h in parentheses. You see, I just grab, whenever I saw an x here, I put x plus h. Everything else is the same. All right, and then I copy. F of x is just copying the original function. Nothing to do there, just copying all over h. And now this one is that one that you need the trick for. And if you don't do the trick, this limit doesn't quite work. Let's see, I think I can fit it. Probably I can still fit it here. I'm going to keep this small. I'll have to erase, I know that. So let's multiply. You see, I told you parentheses were important and I didn't write it. And this is the risk right here. What happened to my 2? I have to distribute. I didn't do it. That's where, excellent example why your parentheses are so necessary. There you go. So now I'm going to grab this, and instead of minus, I'm going to do the conjugate. All right, so yes, you're going to say, you started with something quite benign, and you made it horrible. Good job. But it's not horrible because you look at this here. I have a minus b, call this guy a minus b, times a plus b. You guys remember, a minus b, a plus b is a difference of squares, so you get a squared minus b squared. So now I can apply that here, copy the limit. So I get the square of the first one, let's call it that, minus, that's my a, or my a squared in this case, minus the square of the second. But the square of the square root, it just cancels my square root all over h that multiplies that mess. No worries about it. You have to just copy it. No two ways about it. 2h minus 1 plus 2x minus 1. Okay, and close your parentheses there. So just copy that one. We cannot do much about it. So now the beauty of it, and I'm going to just condense it because of space, you have 2x minus 2x goes away. Negative 1 minus negative 1 is going to be negative 1 plus 1, cancels as well. And just as before, I'm going to be left just with something that depends on h, and I'm going to be able to compute my limit. And that's the trick. You want to eliminate that h that appears in the denominator, and it's right there. So you get 2h over h, that will cancel, then the square root of 2x plus 2h minus 1 plus the square root of 2x minus 1. And there's the parentheses there. So I already used this. I can get rid of it. But now I'm able to, let me just do that actually. I'm able to cancel the h that multiplies with the h that divides, because it multiplies everything and divides everything. So let's copy and go to the top to complete our derivative. Let me eliminate this. And I think I can fit the rest of the problem right here. Okay, so we have then that f prime is equal to the limit as h goes to 0 of 2 over the square root of 2x plus 2h minus 1 plus the square root of 2x minus 1. I'm just copying everything I had here, just without the h. But now notice that if I plug h equals to 0 here, I have no problem. I can plug it in. And in fact, if I'm going to plug it in, I don't need the limit anymore. Let's not do it. So if I plug h equals to 0, I get 2x minus 1, because the middle term, that 2h, becomes 0, plus 2x minus 1. I have a square root of 2x minus 1 plus square root of 2x minus 1. If you think about this as a quantity b, you have b plus b, that's 2b. And to be or not to be becomes this right here. And now I have a 2 that multiplies and a 2 that divides. I can cancel it out, and I get that the derivative is 1 over square root of 2x minus 1. And that's going to do it for today, guys. Thank you so much, and I'll see you in the next one. And thank you so much for having